Professor Billard is head of the Learning Algorithms and Systems Laboratory at EPFL, lead of the Innovation Booster Robotics, and vice president of the Swiss Robotics Association. Guillem Martinez Roura is Artificial Intelligence and Robotics Program Officer at the International Telecommunications Union, the United Nations Specialized Agency for Digital Technologies. Alberto Bombelli leads mobile robot deployment for maintenance in the Gotthard and Chenery base tunnels. His work focuses on operational innovation and continuous improvement, with activities that include simulation and modeling of complex assets, building information modeling maintenance design and deployment, top-down and bottom-up continuous improvement activities, research, and development of predictive maintenance. Sylvia Stocker leads strategic initiatives at Arabesque that help organizations automate, scale, and redesign collaboration between humans and machines. Under her leadership, Arabesque supports global companies in deploying service and humanoid robots, advancing human-centric and sustainable innovation. Sebastien Perroud combines deep technical expertise with strategic mergers and acquisitions experience. He has successfully integrated multiple companies across Europe and North America, building a global platform for scalable and modular automation in manufacturing. His leadership focuses on uniting people, technology, and processes to create lasting industrial value. Professor Anna Loret-Fritchie leads the Fabrication and Material-Aware Architecture Research Group, exploring how digital fabrication and robotics can enable sustainable and resource-efficient construction, particularly with earth and concrete. Co-founder of Foldcast, she bridges architectural design, material science, and digital innovation to advance the future of sustainable building technologies.
Wonderful. So we have here a fantastic panel who can answer most of your questions, I hope. And I would like to encourage you again, as I said, to go on the website on Slido and start asking questions. We're going to take them as they come. But I'm going to get this panel kick-started with a question of my own. Clearly, we think about sustainability in robotics as a way to measure how much impact robotics is doing on the world at large, and we would like, if at all possible, that this impact is minimized or even that it contributes to a reduction of the CO2 emission and any other damages. But a very quick question is, how do we guarantee that? How do we measure if we were to actually, because we're scientists, right? We like to measure things. So how can we measure the complete life cycle of our robot and its activity in the world? Do you have any thought about this? Should we measure it? Should we develop some sort of an eco-label? And if so, what will be the challenge to achieve this? So I suggest we just go one by one.
Okay.
Anna?
Yes, so I think I'm coming from the construction sector, looking as an architect at the entire new abilities that we see with using less materials. And I think we started out by saying we want to use less materials. We use the technology available to enable this, but I think we have reached a point now where we need to look at it as an entire ecosystem. I think we need to look at what is the robot you're using, what is the energy consumption of the robot, what is the longevity of the robot, and how can we implement it also between the construction sector and, let's say, inside of the human-machine collaboration, as we also saw in the work today of Stefana. So if we don't look at it as a holistic process, I think in the measurements of each single point, from concrete material, in my case, to the usage of energy for the production, we could end up greenwashing the use of robots. So I think there needs to be some labeling. Yes, exactly how and how much is then the next question, where maybe somebody from industry can give a better view on that.
Yes, so indeed I'm coming from the industry, so for me the full life cycles is not ending while we deliver the assembly line. So usually what we do is we deliver assembly line with multiple robots in them, and assembly line, they are dedicated to assemble parts for a dedicated period of time. And then the question is, what after the line has been run for a few years? Usually, lines are nowadays at a level where we can retool the line. That means that we can reconfigure the line for the next generation of product, and usually we can do that for maybe 1 times, 2 times, and then what's next? So nowadays you see plenty of factories all around the world that have robots and assembly line that are there, and then what's after? So once the line is, let's say in a decommissioning phase, retooled 1, 2 times, and then the line ended up being scratched, all the time scratched somewhere. And I think that here there is something that can be done with modular platform, modular automation, maybe also on the robotic sides, or can we put robots together that can be back to the factories, reuse again, and then to create a kind of a circular economy around that. Today, there are ideas, but we are not yet here. And I know that this is also one of your specialties, so maybe you can elaborate a little bit more on that topic.
Yeah, I'd love to. Hello, everyone. So I'm coming more from the business side, and I'm also coming from the side of service robotics, which is kind of a new field, right? So there are no standards as I know of in the last 10 years. We have discussed, but honestly speaking, we have discussed this very little so far. I think one of the thoughts which is interesting is that we work with the RAS model with the robots, which is for 1 year, 2 years, 3 years, a subscription model. And then obviously my clients, they want the latest robotic model for their use cases and their automation. So we get robots back. And what do we do with these robots? And we don't have a solution nowadays. Maybe you have some creative solutions. I have some ideas I came with. And one of the ideas I think could be very beneficial is to foster education, which is also a SDG goal, number 4, education. Foster education, bring those robots into education for kids to actually learn about robotics and AI and get these robots to the schools to reuse them. Please.
Yes. So I do agree, especially on this last point. A school can, of course, benefit from robot, not only from the virtual reconstruction of the robot, but it's also really interesting to see the reality, the practical problems that you incur in programming a robot and so on. I also think that it's important to have a label that talks to the consumer and talks to the population, because often you have a plethora of labels. Every label has its rule. It's not kind of unified, and you are really buying something with a label, and you need to study the label in order to understand what the label means. So that is also a really important point. I also think that the life cycle of robot is quite important. Also the commissioning, as it was pointed out, but also the social impact of the sustainability of the robot, which is very, very difficult to quantify.
Yeah, so thanks for these initial remarks from our panelists. We would like now to focus on governance and regulation. And our next question is about which regulatory frameworks are necessary to ensure that robotics deliver meaningful, equitable, and sustainable benefits for everyone, especially in underserved regions, and how can we avoid unintended harm? Who would like to go first?
Well, maybe just in terms of regulation, I can just put my point of view of that. So regulation is good, but that should not stop innovation, in my opinion. So this is the first thing that we see. Sometimes regulation can also stop innovation by putting too much rule. So I think that regulation is something important, but that should be done more on the incentives way, so not really blocking things, but more promoting new technologies on the incentives program instead of having, let's say, regulation that can stop putting new products or new innovation on the market.
And another question that is coming from the audience is about who should oversee all these sustainability policies? Who should be politicians, environmental scientists, or engineers? How should these be implemented?
I think there is an issue that needs to be discussed, which is what are we using the robots for? And of course, at the moment and over the last, let's say, 2 decades, robots have been for efficiency mainly. But today we saw very beautiful examples of how we can actually convey or move towards more complex systems. First of all, with the Amazon measuring the DNA of plants to predict, let's say, diseases happening. We also saw the agriculture, where we see very little material being placed where it's needed, and this brings me to my own field of construction, where, for instance, in 3D concrete printing, which I think most people know, you can really place material as it's needed on the spot. And I think it's not all about efficiency. We have to stop thinking only about efficiency, but also of reduction of materials, and then we need to think of robotics as more open systems, more modular systems, where I think, in a way, the construction sector took this quite nicely on board. Many of the robots used in construction architectural research is really coming from automotive industry, surveillance industry, and you name it, to actually enable the use of less material, more, let's say, control systems. We saw the very complex waste generation of walls from Stefano today, and there are others that are popping up as spin-offs that really use robotics to work with complex systems that a human could not do before. And there I think there's a huge potential that we shouldn't lose that train on the way, instead of just saying we move towards efficiency, because then we are using them for greenwashing in a way. So I think we have to find a good balance there. I see you are not so happy with my comment there, but I think there is really a thing. If a robot only lives for 8 to 10 years, I'm sorry, we heard about the amount of materials that is inside the machine. We need to think of modular open systems and how to reuse them beyond education, in my opinion.
Yeah, and I think this really is in what we started and kicked off the discussion on how we looked into this full life cycle of the environmental footprint of robotics. And I think this includes raw materials, extraction, manufacturing, deployment, maintenance, and of course, potential reuse of these robotics components. And and the audience is asking about this as well, why sustainability in robotics lacks these current standards, these metrics? Is it an insufficient research? Absence of regulatory initiatives? How can we ensure that we have methodologies to assess the environmental footprint of robotic systems to ensure that they contribute solving global challenges like the ones we have seen in previous presentations, but at the same time, we ensure that these robots are sustainable by design? Please.
There is one thing which comes to my mind. Why are we maybe lacking these regulations? It's because it's a race. It's a global race, especially in service robotics, humanoid robots. It's a race. Like, everybody wants to bring out the robots as fast as possible with the best technology. And I think the sustainability is a little bit, put back to actually bring out robots. That's one point. And the other point is, what about the human-centric approach? I think that's super important, because at the end of the day, we want to automate tasks to actually serve us humans. And I think that's also an important topic to bring into this discussion, so we don't leave that out at the end of the day. Sustainability, yes, but also it has to be in a human-centric way. Okay. So the race and the human-centric point.
Yeah, thanks for this. Maybe Professor Billard has some questions for the panelists.
But I'd like to turn to the audience, and maybe you can raise your hand. How many among you have robots in your lab, in your industry, that at some point happened exactly what's been described before, you stopped using them? How many of you have that? You stopped using them. Right. So what did you do with them? You discarded them, you put them in a cupboard, or did you try to reuse some parts? How many discarded that? most people. Okay, so this is a true issue. And yes, there is a race to humanoid robots, for sure. And my biggest concern, aside from the fact that there is all these CO2 emission issues, is the fact that also it's going to be really difficult to transfer from one slate of robots what we've been training those to do to another, big slate of robots. So for sure, we will have issues, and addressing both the reusability of these robots may solve both the economic issue of, upgrading your fleet of robots, and also addressing all of the issues that have been mentioned here. So again, turning to the room, how many people would be open to really having some form of an eco label for your robot? A few hands. Okay, so you may want to go now on the QR code and fight. Ask tough questions to the panelists. Why do you think it's maybe not relevant? Why do you think eco labels are not relevant? Maybe we can take that next. But I can piggyback that to the panel. So what do you guys think? Where is the trade-off? What are the pros and cons of having such eco label? Clearly, some people will show resistance to that.
Well, of course, one of the main drives of sustainability is the consumer. And often the robots, or now, since we are not in a mainstream culture with robots, the consumer is not yet touched from the robots. So this drive is still missing. So if we would have a eco-label, it would have to come from top down, so from the state, from something like that. But we have seen in the past that this drive from the end consumer is really strong, and it has driven globally the sustainability talk. So I think we are not yet there, but in regards of the methodology, the quantitative methodology for the environmental sustainability quantification is there. It's a consolidated method. What is missing for me is the social sustainability method to characterize what is the social impact on a society of a robot that can do this or the use case of the robot.
Yeah, and we have right now, as we discuss about sustainability, there is the COP 30 going on in Brazil, and some of the green digital, as part of the Green Digital Action Initiative, there's current work on from standard setting bodies working on clear and comparable methodologies to measure digital systems. And in this case, we are currently focusing a lot on AI systems. How can we bring these current methodologies that are being conceptualized for AI systems to robot systems? Do we need new methodologies? Can current methodologies be applied to robotic systems? I don't know if the audience, like really moving from these more high-level principles on sustainability to practical implementation through a standard setting in embodied AI and robotic systems.
Maybe it's a bit off, but I think there are some different aspects to this. It's not like a one-of-a-kind answer, but for instance, you mentioned education. I think we need to educate people. The next thing is we need to look at these systems. We've gone through now a couple of decades of closed systems in cars, radios, you name it, all electronic devices. You can't open them up, you can't repair them. Now we're entering an era of repair, repairability, open systems. We see all these pop-ups of people repairing things again, as we saw it in the 70s and 60s. Televisions were repaired and lived for 20 years. So when we talk about sustainability, we also need to think, and labels, we need to think about open systems. We need to think about things that can be opened up. They need to be repairable. We need to educate the next generation to be able to repair all of these machines and maybe take out things and put them back together in another machine. But there has to be some kind of a let's say, storage room for all these different motors and controllers and all the things that we are using in robotics that can be reused or reconfigured. And right now we're moving towards very closed systems. Yeah. And I think we have to be careful here not to repeat that kind of, let's say, closed system development that we've seen in the last 20 years in industrial design. So this is really a big point of, do we have to regulate this? I'm not sure. I think everybody has to move towards that more open modular system of things.
Yeah, no, thanks for this. So so maybe regulation has, of course, like all these tricky parts, but how can we support, even if it's not regulation, how can we support the development of these robots, both in hardware and control, that are sustainable by design? Are there any incentives, regulatory, financially, or market-based, that could contribute to these more sustainable robotic systems?
Maybe what I see in the evolution of the robotics is that basically talking about industrial robotics is that the key kinematics of the robots, what you see today in the market, they have been invented in the 80s, something like that. So basically, all the industrial robots nowadays, they look very similar, what we see. But what evolved really a lot is on the software, on the control. And usually, the obsolescence of a system, of a robot, the way that we cannot reuse one-to-one a robot that have already been since 10 years in the industry, usually is bound to the control. The control make a huge step forward, and we are blocked because of the control, new functionalities, and so on. And then just to make a bridge to what you were saying as a question, maybe AI could be, at a certain point of time, helping that to close that bridge in terms of software, so making able to use all mechanics, all gearbox, all motors, the mechanics of the robots, and then bridging that with some new software around the controller to bridge that gap. So maybe there is here a way, an idea, or we can bring back this kind of robot in production line even after 10, 20, 50 years already used in the industry.
Yeah, no, and I think many of the questions from the audience, and thanks again for the questions, look as well into how we can train engineers from the outset into these sustainability issues, like to ensure more like sustainability in the design. Some relate as well how to not only link the sustainability issues when it comes to the robotics part, but as well to the robot use and AI training part, because many of the robots that probably you are developing in your labs, you're adding this AI component. So it's like the hardware and the software part that get combined. But I think if maybe to wrap up this panel discussion, what it would be for as this a panel that looks into the global priorities when it comes to sustainability in robotics, like both the two modalities that we mentioned, what would be for you the top global priorities to ensure that we can move forward to these sustainability robotics in the real world? Any of the panelists?
I don't have the top answer, but I think there are two parts. The one is the production and the other one is the disposal. So in the disposal, I can say out of the business perspective, I mean, that could be a solution to talk also to clients and make sure we address it from the beginning when we deploy the robots to find some maybe new ways to actually bring in this topic right in the beginning when we deploy the robots.
Okay, thanks for this. Maybe any other?
Yeah, I think that also in our everyday reality, we do pay for the disposal upfront for all kind of electronics. So why not for the robots? Why not for the B2B community as well?
Okay. Maybe any other of the panelists, or maybe Professor Billard has some closing remarks in this regard.
I believe it's a very important topic that we have just touched upon for the first time in this, and there are many questions in our heads for all of us. I don't want to eat up more time. You've noticed that unfortunately we are not very Swiss and we're a little bit above the time that was allocated to us. So I suggest we stop here. We really thank the panelists. I also thank the audience. And let's take those questions now at the coffee break. So thank you very much, everybody.
Thank you.